One.
Hello!
We are Solarpinnacle, and we are one of the teams competing at the Solar Car Challenge. Now, we are a team made up from sophomores to seniors, all collaborating to prove one goal, and that is to build a solar car that satisfies the rules of the Solar Car organization. Now, in this process, we aspire to learn skills of trade such as mechanical, electrical, and administrative sectors. But above all else, we aspire to learn about teamwork in the process and an engineering endeavor.
Our model serves as our guideline for the building process of our car. To compensate for late arrival of our materials, we decided to make our model a lot more detail-oriented. This helps us to jump in immediately once our materials arrive and start building the car with less mistakes being made.
All right, taking into account the failures of our past years, this year, we decided to expand the driver's compartment. This allows for the driver to be able to escape easier and also be able to see better on the road, as the years before we had our solar panels on the body of the car, which would make our driver's compartment smaller, which would obstruct the driver's vision whenever our legs would be up.
So this year we decided to add a roof so we could place our solar panels on top instead of on the crush zone. As a result of, because of the fact that our roof's frame is too flimsy, we decided to add cross beams between the edges of the roof. This would allow us to ensure rigidity of the roof and allow us to place the solar panels on top.
Because of the new roof design, we're able to shorten the crush zone and change the thickness of 1 inch, 1.5 inch, half inch to 3/4 inch.
Last year, our windshield design was flat from the top of the driver's head to the main chassis, which ultimately gave this limited space for a driver to escape. This year, our drivers did get bigger in length, so in order to make an escape path easier for drivers to follow, we decided to curve our windshield this year.
Now, while creating our windshield, we used steel flats as a frame to place our windshield on top. Between the windshield and the steel frame, we added mounting tape and foam tape. This would absorb the shock while the driver is driving and prevent cracks on the windshield. With the addition of a roof and a reduced crush zone, this no longer means that we need a lengthy car. Last year we used leaf spring suspension, and this contributed to the length of our car. This year we opted to use shocks instead because it reduced the length of our car as well as ease of installation.
For our brakes this year, we decided to go back to mechanical brakes due to the fact that hydraulic brakes last year caused a lot of problems due to leaking and a hard setup. For our safety cell, we decided to keep the same design with just a bit of tweaks. Due to the seat dropping and the driver's compartment getting bigger, we decided to add a vertical crossbeam in order to protect the driver's head and a diagonal crossbeam in order to protect the shoulder and the arms of the driver in case a crash were to occur.
Our current barrier box uses similar features as our previous barrier box with some modifications to abide by the new rules and for ease of use. Since we're using lithium ion phosphate batteries, we're not including any space for fans this year. And as opposed to having large holes in our barrier box to funnel out our wires and having messy wiring, we are using a cable organizer to funnel out our wires, and we're using silicone around that to make our battery box airtight.
This year we bought a new motor, and with the new motor we have to build a new motor mount. So for our motor mount, we took inspiration from an old team, and we really liked some elements, so we modified it and added supports so that the motor would better sit in the back of our car rather than the side, because that would offset the weight. And we also screwed in the motor with some steel flats so it wouldn't wobble around or fall off in the event of a rollover.
With the added space in the driver's compartment, we decided to keep the auxiliary systems next to the driver for easy access. We made a plexiglass lid for aesthetic purposes, but not only that, but for the driver to diagnose the malfunction of it on track so the crew can come prepared and for maintenance at pit stop.
The new motor is also very exciting because it'll be able to handle our car way better than last year, giving us more speed with less effort. Our batteries and solar panels are wired in series so that we can obtain the amount of voltage needed to power the motor. The solar panels are the same as last year, but their new position as a ceiling is an improvement that will allow the panels to gather more solar power. And the MPPT, fuse, and relays are also safer with our bettered enclosure.
Our auxiliary system was made inside our electrical compartment, which was made specifically as an easy-to-access port, where all the wiring will go through a small cable tube management. Our auxiliary system schematic was made as a easy-to-read illustration for all our members to get an idea of how our wiring will go throughout the car.
Now this is our entire electrical system. As you can see here, we also include the motor, the solar panel, battery, as well as the auxiliary system and a giant schematic, as you can see here. Thank you.